Hey everybody, this is Larry. This is day 4 of the Leetcode Day Challenge. Wow, it's already been 4 days. It's only been 4 days. Hit the like button, subscribe button, join me on Discord. Let me know what you think about today's contest or today's farm. I don't know what I'm doing anymore. But yeah, today I kind of landed, or when I was running, I kind of hit my, I don't know. It's not a sprain. I kind of sprained my ankle, kind of not. I don't know. It just hurts. It's a little bit sore. So I'm kind of taking it a little bit easy today. Just kind of walked around a little bit just to kind of keep it active. But otherwise, Vice, have my foot up and all this stuff. We'll see. Hopefully it's still fine, but no update there. So today there is crazy things going on. Hope everyone's okay with the stock market and stuff. Let me know in the comments how you feel about everything going on. Today feels like forever in that kind of thing, but yeah. All right, let's take a look at today's farm. We have 1123, lowest common ancestor of deepest leaves. Okay, what does that mean? Given the root of a binary tree, return the lowest common ancestor of its deepest leaf. Lowest common, what does that mean? Okay, so the deepest leaf is 7 and 4, so okay. I mean, I think okay, what is the deepest leaf mean? Okay, let's see. Okay, the depth. Okay, the lowest is the lowest common ancestor of a set S of nodes is the node A with the okay. But what if they're tiebreakers? I guess that's the question. That's what I'm trying to figure out. And apparently it's the same as another problem, but that's fine. Man, do I have reading problem these days? I don't know. Okay, I mean, they don't. I feel like why do I struggle so much these days with reading palm? I feel like maybe I'm just not reading minds correctly, and that is honestly it is a skill in competitive because you have to be able to read these quickly. But clearly, I'm not reading it that quickly. I mean, I know these things are whatever, but but I honestly a little bit don't get it in the sense that like. Just like yeah, like it's a little bit vague, right? Like there could be multiple deepest leaves, and maybe we can assume that doesn't just because otherwise it's hard to solve. But excuse me. Oh yeah, I'm also dealing with that allergy season. Okay. 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 But yeah, how do you define the deepest load? I mean, I guess we'll figure it out. So if there's only one deepest node, then it's itself. So okay. So maybe if there are multiple deepest, then we just kind of we find the common ancestor of all the deepest. Maybe that's it. Okay, let's go. Then yeah, let's. I mean, it's fine. It's just that I wish it's a little bit more precise because there really is no reason to not be precise. But yeah, first of all, I want to traverse the tree, right? Just kind of figure out what node is the deepest, so we can kind of do something like this, right? We could do traverse. We could even. I want to think whether it's better to do depth first search or breadth first search. I don't think it matters that much, but in theory it can, right? So yeah, so no depth, right? So here we go, if node is none, then we just return. Otherwise, yeah, if node.left is none and node.right is none, that makes it a leaf. If it's a leaf, then we check whether the current depth is if it's greater than max depth, then we have deepest is equal to, technically we set a, that's a little bit awkward, but okay, that's fine, I think, maybe. Right? And then if depth, and then we update depth, right? And then if depth is equal to max depth, then we just append node, right? And that's really it. And that should be good enough. I mean, well, as long as you also do the obvious thing of looking at his children, which I guess sometimes I'm not a good parent because I forget about the children. But yeah, and then now you have the deepest, right? And then there are a couple of ways you could do to get the LCA, and there may be more funky algorithms, but and actually maybe I don't want a list. Maybe I want a set. Yeah, let's make it a set. And here maybe I could, because I do remember reading the nodes being unique, so we can just add the node, was it .wow, right? And then now basically deepest will contain all the things. And then yeah, now we want now that we have all the nodes in a set that we care about, that they all have the same depth, all we have to do is just get the lowest node that is an ancestor of all the nodes, right? So maybe we can have, and it should be the first node where this is the case, right? So basically maybe these tree problems, sometimes it makes me write very ugly code, and yeah, I don't know what to say, but yeah, maybe we could go just like find given a node, right? And again, if node is none, then we just return. Otherwise, we want to say, yeah, maybe find, I don't know if find is quite the right word, but the idea here is that we just get, yeah, so if node.value is in, what do they call it, deepest? Yeah, if it's in deepest, then we just return 1, because we only add these to the deepest if it's already a leaf. That means that we don't have to check the leaf in this case, right? Otherwise, we can go find that node.left, find that node.right, and then this is like a left count. This is a right count, right? And we only care about leaves. So if left count plus right count is equal to length of the deepest, then that means that we're good. But only in the first instance, right? So if found is none, then found is equal to node. And that should be good. Oh, wait, what? Why do we return? Why does this return 3 things? Am I confused? I am very confused, but oh, wait. Oh, no. You just, this returns to 2, but the output is very confusing looking as well, because that's their string version of the tree node, because 2, in the way that they print out the string, is recursive with a subtree. So it's a little bit confusing, but I think this is fine, right? So we just return found, and we should be good. We maybe have need a non-local found here, right? And we return left count plus right count, right? And that's it. I mean, I'd be wrong, but that's it. Okay, well, we just return. So we don't find anything ever, huh? Why is that? Let's see. Let's take. Man, these days I am struggling. I feel like this should not have been that difficult. But okay, let's take a look at the type booking things. Okay, so yeah, okay, we're just not adding to the set for some reason. The depth is, huh? I don't know why this doesn't complain. Oh no, well, it should complain anyway about about this, but the reason is also because we don't do a traverse. I don't know why I'm so bad. I'm so bad. Sorry, friends. Right, so we do a traversal, and then we also want to call the find function of the root, right? And yeah, is none. Left count. Oh, I don't return. Yeah, there you go. Okay. This is right. This is not right. This is. This returned the parent of 1. Oh, because I returned 1 on the leaf, so it doesn't ever. Okay. I guess we just have to check it, really. Yeah. Okay. Fine. Eh. Is it node or node.drive? Okay. I'm so bad. Sorry, friends. This code isn't even good, so my apologies. But I mean, it works and it's linear, but it is definitely not very pretty. Yeah, so we do 2 scans. This is gonna be linear time, linear space, right? Because of the stack space or O of H, where H is the height of the tree, if you will. I don't think I mean, I guess technically on the deepest level, it can always be n over 2 nodes, right? That's how the tree works. So I guess it's n O of n space with respect to the deepest thing anyway. But yeah, okay, fine, right? Yeah, that's all I have for this one. Let me know what you think. Thanks for watching, and yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.